Okay. So in this video, we're going to use the fzero function to find local minima and local maxima for the expression y is equal to x sin of x. In the last video, we used the f minbound function to do the same, and the only thing that's a bit more different about fzero function is that it involves a step of calculus, which I think is what makes using fzero function a bit more interesting as opposed to f minbound function and the min and max functions to find local minima and maxima. So here we have x is assigned in space 0, 6, 101, meaning that x goes from 0 to 6, and it's a vector of size 101. Now our function once again is f is equal to at x sin of x, and our first derivative, which is the step of calculus I was talking about, I'll call it f prime. So f prime is assigned at x sin of x plus x cosine of x, which is the first derivative of this function right here, of this expression right here. Now we're going to find the local minima for this function, and then we'll find the local maxima. We're told that the minimum occurs roughly at 5, -5. So that comes from this function right here. This is what the graph looks like. And then the local minima occurs roughly at 5, -5, and our local maxima occurs at roughly 2, 2. So we'll find the local minima first. For the first line of code you will write for this, on the right hand side, you will write the fzero function, and inside the fzero function, instead of putting f, you'll put f prime, because when you do the first derivative test, you set this expression equal to 0 and then find x. So you'll mathematically speaking, what you will do is you will take sine of x plus x cosine of x, set that equal to 0, so set this part equal to 0, and then solve for x. So this is what the fzero function does. It will take this function, set equal to 0, and then solve for x. Now the second thing you put in here is your guess as to what the x value should be, or roughly what it should be. So we'll put a 5 here. And on the left hand side, what this variable will give you is the value of your x. It will give you the value of x at this point right here. So I'll call it x min. Now if you run this, you see that your x min is equal to 4.9132, so it's assigned that value. Now if you think back to any of your math classes, you know that if you have a value of x, you can get a value of y by plugging in the x into the f of x function. So that's what we'll be doing. We'll say y min is assigned f, and then we'll send it x min. So what this will do is it will take this number right here, 4.9132, send it to f right here. So we'll send it 4.9132, and then it will get a value out of it and assign it to y min. So now if we run this now, we see that x min is 4.9132 and your y min is -4.8145. Now these are the minimum x value and the minimum y value. These are the x and y values at which the lowest point occurs. Just keep that in mind. So you have 4.9132 and then -4.8145. So they're both close to 5, -5, so we'll say that's right, and then move on to local maxima. So for local maxima, you do something very similar. You'd say x max is assigned f0, and then you once again send it the function handle f prime, comma. This time our guess should be 2, so we'll put a 2 here. Now, the next thing you do is you say y max is equal to, once again, f, and you send it this x max. So you're sending it a value of x to get a value of y out of it, basically. So if you run this, you see that you get 2.0288 comma 1.8197, which is close to 2 comma 2. So we can say that's right. So it's simple using this too. It involves one step of calculus, and after that it's just the same process to find the min and max. So that's about it. If you have any questions about this, let me know. Thank you for watching.